Okay, we have here today a really interesting problem from the UNSW Integration Beat 2023 Semifinals Round 1 Problem 4. We have the integral of 0 to pi over 2 natural log of sine x dx. We're going to do some familiar things, but there's quite a few twists to this. So what I'm going to do to start is just noticing that we've got our bounds going from 0 to pi over 2. In this case, especially with a trig function, the kind of substitution I like to make is setting u equal to pi over 2 minus x. And then, of course, solving for x, we can do it this way as well and have this. Taking our derivative, dx is going to be just minus du. Then I'll make this substitution, and this is going to kind of flip our bounds around. We plug a pi over 2 in here, we get 0. We plug a 0 and we get pi over 2. Next we'll have natural log sine, but then for x I'm going to use this. So we'll have pi over 2 minus u. And then our dx again is minus du. And what I'm going to do is take this minus sign, bring it out front, and use to flip our bounds around. So we're going to just swap these and get it back to what we had in the original. We're going to be going from 0 to pi over 2 now. And next what I'm going to do is I just want to notice here sine of pi over 2 minus u. This is just the complementary angle formula. So this is going to be the same thing as cosine of u. So now what I'm going to do is I'm going to rewrite this. We're going to have cosine of u, but I'm also going to do one other thing. I'm going to move this closer. So now I'm going to rewrite this, and we're going to have cosine of u in here. But what I'm going to do while I'm doing this, I'm going to change the variable to x. Just notice because it's a definite integral, changing the variable is not going to bother us. So I'm going to change this thing back to x. That's not the best integral sign, but I'm just going to deal with it. So we're going to have natural log cosine now of x dx. And now this is kind of interesting. We had our original integral that I'm just going to label I, and this is still I. All we did here is transform our sine to cosine after a bit of work. So what I'm going to do is add these two integrals together and see what happens now. So now we have natural log sine x plus natural log of cosine x. I think what I want to do now is just kind of do all my algebra on the side, because we have this, and by the property of natural logs, I can combine these, right? So I can write this as natural log of sine x times cos x. But then notice the similarity to the double angle formula. If I just would multiply by a 2 here, that's going to be the same thing as sine of 2x. But I don't want to change this, so I'm going to also divide by 2. So all I did here is multiply by 1. And then from here, again, by the property of logs, I can split this into like subtraction. So I can write this as ln of sine of 2x. And then we have our 2, so I'm going to write this as minus ln of 2. And then so when I rewrite the integral, now I can split this into two integrals. So we're still working with two copies, 2i, and we're integrating from 0 to pi over 2. The first integral is going to be natural log sine 2x. Now for this other integral, when I split this out, I can actually, because this is a constant, I can bring this out front of the integral sign. And now we're just integrating over here, we're just integrating 1. Okay, now I think I'm just going to deal with this thing really quick, because we know the integral of 1 is just going to be x. And so we just need to evaluate this from 0 to pi over 2. The 0 is not going to matter, so this thing is actually going to be equal to just pi over 2. So for this piece over here, we're just going to have pi over 2 times natural log of 2, and we'll just bring that down. But now over here, the thing I want to notice with this integral, it's kind of really similar to our original integral. The only thing going on that's different is this 2 here. So what I think I'm going to do here is let's just do a u substitution. Call my u equal to 2x. I'll take a derivative, du equals 2 dx. Then I'm going to just make this substitution and see how it goes. So let's see, we plug a pi over 2 in here, we're going to have pi for our upper bound. We plug 0 in, it's still 0. This is going to transform into natural log of sine of u now. Now here actually, I'll just solve real quickly for dx. So dx is going to be du over 2, or 1/2 times du. So we'll have our du here. I'm just going to take this 1/2 and bring it out front. And let's bring down this whole mess. So this is going to be just natural log 2 pi over 2. So the interesting thing now is this is the same as this, different variable, but same idea. But we got our bounds are different. So what I'm going to do is I want to do one more substitution and get my bounds to look more like this. And the way I'm going to do this, I'm going to go back and kind of do the substitution we did earlier again. We're just going to do the same substitution we did before on this thing. It's just going to be a little bit different now. So when I do this and we plug in pi, here for our upper bound we end up with minus pi over 2, right? Then I plug a 0 in here, the lower bound becomes pi over 2. We know how this is going to go because we just did it. This is again going to be the complementary angle formula when I plug in for u, where we plug in pi over 2 minus x. So this is going to become sine of pi over 2 minus x, but I can write that as just cosine of x. And of course, if dx is minus du, then du is minus dx. So I have a minus dx on the end here. But again, I'm going to use this minus sign just to flip my bounds like this. So this is going to become positive and this is going to become negative. Okay, now at this point you may see what's happening. Natural log cosine x, this here is an even function. It's even because cosine's even. You plug a negative x in here, the cosine's just going to turn to a positive x. But we also have symmetric bounds here from minus pi over 2 to pi over 2. So an even function, symmetric bounds, what this allows me to do is turn my lower bound into 0 here, and then multiply by a 2 up front. That's pretty nice, 2 times a half, that's going to give me 1 right there. But now at this point, integrating ln cosine of x from 0 pi over 2, I erased it from the previous board, but we found earlier that that was the same exact thing as our sine of x. So this thing here is also I. So now that's just telling us that this integral right here, this thing is also I. So now I can really clean this up. I think I will try to squeeze it in right here because I don't need a lot of space. So we're going to have 2 copies of the integral 2I is going to be equal to this I minus ln 2 pi over 2. So now all we need to do from here is we just need to solve this for I. But I'm just going to clean up the board because I don't want to end up running out of space. Okay, now just to finish this off, remember our goal is just to find this I. That's the integral that we're after. So all I need to do here is solve for I. So what I can do is subtract an I from both sides. Here, this is going to cancel. Here on the left side, we're just going to end up with I. And then here, for my solution, one thing I'm going to do, I'm going to take this minus into the exponent. I'm trying to match UNSW's solution. So this will be fine leaving it this way. But instead, by bringing that to the exponent, I can write this as natural log of 1/2 times pi over 2, and that's it. Okay, really like that one today, so we'll stop it there. Thanks everyone for watching. Have a great day.